Welcome to Brainatic. Today we'll learn something which could be a fantastic project for students during their course, especially college students who are pursuing something or some course in degree in engineering or technology, and especially for people who are in computer science, electronics, electrical. So a lot of people, they could start working on this by themselves. So what happens is that a lot of people find this project very interesting and a lot of people pursue a career in this domain. Yes, I'm talking about memory. So a lot of times you might have heard about SRAMs. Okay, so today I'll teach you like how to actually draw the static noise margin of an SRAM using Excel. Simple as that. You don't need very high-tech softwares or highly paid softwares for that. Simple Excel will do the job for you. Okay, so first a few theory which is needed. So what is SRAM, static random access memory? Why is it static? Because we use back-to-back inverters to store the data. As you can see, these are the back-to-back inverters which are storing the data. What is a DRAM? Dynamic random access memory. Now in DRAM we use a capacitors to store the bit data. Okay, now as you can see, I'm having two back-to-back inverters. These two are my access transistors. These two are my access transistors. This line connecting these two access transistors is the word line, and this line is the bit line bar and the bit line. Okay, now my word line acts as a selection device, and my bit line bar and the bit line usually act as an input and an output. Okay, so signal basically, not a device, signal. My word line acts as a signal for selection, and my bit line bar and bit line act as a signal for input and output. Now just a broader picture of this is this one over here. I've opened up the two inverters. The symbol which was shown over here is opened up, and as you can see, the output of this inverter is getting connected to the input of this inverter, and the output of this inverter is getting connected to the input of this inverters. These two are the access transistors, and Q and Q bar are the data in which I'm interested in. Okay, now let's head forward. So for static noise margin, we usually take one side of the inverter to draw. Okay, be it hold margin, be it read margin, or the write margin. Okay, we take one of the inverters. You can either take this side of the inverter or you can take this side of the inverter, any side of the inverter. Now I'm using electric for schematic purposes. So as you can see, I've taken one side of the inverter. My Q is coming in as an input. You can just easily map it to the figure in the right side. Okay, my Q is coming as an input and Q bar is my output. Let's see it again. Yeah, my Q is coming in as an input, okay, and Q bar is my output. This is my access device. I'm selecting it for you. This is my PMOS and CMOS of the NMOS of the CMOS inverter, and this is my access device, which is usually a NMOS. So not getting into details of the device right now or the structure of the SRAM. This is a simple code which I have written over here. Okay, as you can see, VDD 0.8 volt. This should be V2, just a minute. This should be V2, V2 ground, V3 Q, V4 I'm not using right now, that is Q bar, and I'm just giving a DC sweep to V3 from 0 to 0.8 with steps of 0.01. Okay, so let's go ahead and plot it. So I'm using electric as well as LTSPICE. We'll see the results on LTSPICE very quickly. Here you go. Just to help you with this, right click on add traces. Now I'm interested in VQ bar. Okay, so I'm getting this curve now, which is now comes the important part. Once you have the graph, click on file, then click on export data as text. Make sure you have the file path with yourself. Select which trace you want to get data from, then click on OK. Now I've already had this data printed. Once you have this data, it will be readily available in text format. Open with Notepad. And once you open it, so my work with electric and LTSPICE is over by now. So I'll just close it. Widen this up. Here's my notepad. Copy all the data, Control A C. Come to over here, paste the data. Change the format of the data, format cells, make it as a number, make it decimal up to 3 places, that is up to you. Okay, Now here comes the tricky part. Select this and paste it somewhere else. Control V. Now select this file, copy it, this column, then paste it. Make sure you paste it before this one. Now there's a concept of while plotting graphs in Excel using Excel, X and Y. So I'm just reversing it. You might have methods, but I'm just showing a hint to you or a trick to you. Now once you have selected both these cells, go to Insert. Here you'll find Charts. Click one of them. So you have the one you saw in the LTSPICE. Now select these two. Okay, press Shift and select these two. It will be easier for you. Now come and place Charts. Now you have the second data. Now once you click this, just click on top of this and then click a right click. Okay, select Format Chart Area. A pop-up will come up on the right side. Now click on Fill, make it No Fill, and tada! Here you have your static noise margin, especially for read operation. Now you can work upon this as the way you want. Now some of you might have questions as to we want to measure the area within this. So I have this is a sort of a hit and trial method which I use. So press Shift, only then you will be able to get a square. So what I did is that I came to Insert, I came to Shapes, and I selected rectangles. Okay, sharp rectangles, rectangles with sharp edges. This one. Now press Shift and only then you will get a square. So for this is obviously you're getting a read noise margin. Okay, so just place it properly. I'm doing a bit with you understand, I believe, that this is not a very accurate way of doing things, but more or less this is correct. Okay, now once you have selected this, just come over here and you can see the size, and now you have the dimensions of this 0.61 centimeters. Now you can actually relate this to voltages. Simpler way to doing is this. Come to Shapes again, select rectangle, draw a rectangle over here almost equal to 1 volt, 0.1 volt. So if I zoom in for you a little, I'm touching this boundary and I'm touching 0.1 volt, almost accurate. Now so my 0.1 volt is around 1.18 centimeters. So using unitary methods, you can actually get the read noise margin from this. So I hope you like this video. Do subscribe, share, and tell me what else I can do in the comments below so that I can make new videos for you again. Thank you.